Let's take the derivatives of trig functions. Let's start by looking at the trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. Let's start by looking at the graph of sine x. Using the interpretation of the derivative as being the slope of the tangent line at any given point, let's try to envision what the graph of the derivative of sine x would look like. Well, at all the maxima and minima, the tangent line is horizontal, so the slope is 0. That means the derivative must equal 0 at these points. Now, looking in between, we can see that from this local maximum, the slope of sine x will decrease until it hits -1, and then will increase until it hits 0 again at the next local minimum. So the derivative should look like this for that section. Then the slope of sine x will have to increase until it hits 1, but then decrease until it gets back to 0 at the next local maximum. So the derivative should look like this for that section. This pattern will repeat infinitely in either direction, so the derivative of sine x looks like this. But what is this? The function equals 1 when x is 0, and then goes to 0 at half pi, and continues on in this manner. Well, this is simply the graph for cosine x. So it is the case that the derivative of sine x is the function cosine x. What if we now try to take the derivative of cosine x? Well, let's apply the same logic that we just used, finding where the derivative must equal 0, and the places where it must equal +1 and -1. And we end up with this. This looks almost like sine x once again, as it is equal to 0 at the origin. It is just that it has been reflected across the x-axis, as instead of first climbing up to +1 at half pi, it actually goes down to -1. So the derivative of cosine x is negative sine x.
Okay, so as you just saw in that clip, the derivative of the sine function is the cosine function, and the derivative of the cosine function is the negative sine function. So let me just write those down here. So these will come in handy when we now find the derivative of the tangent function. So let's remember what we learned in a previous class. What is the tangent function equal to? If we have y is equals to the tangent of x, we can express that in terms of sine and cosine. Remember that the tangent of x is equal to the sine of x divided by the cosine of x. So we can now find the derivative of the tangent function using the quotient rule, because we have one function being divided by another function, both of which we now know the derivative of. So we identify our u and our v. We have here that u is equal to sine x and v is equal to cosine x. Therefore, u prime is equal to cosine of x and v prime is equal to negative sine of x. So our formula for the quotient rule is y prime is equal to u prime v minus u v prime all over v squared. So when we substitute into our formula, we'll have the cosine of x multiplied by the cosine of x, take away u times v prime, so that's sine of x times the negative sine of x. This is all over the cosine of x quantity squared. So when we take cosine of x and multiply it by cosine of x, that doesn't give us the cosine of x squared. That gives us the cosine squared of x, which is written as such, where the square goes over the cosine, indicating that it is the square of cosine. If the square went after the x, then that would mean a different thing. It would mean that it is the cosine of the quantity x, which was squared. So this means cosine of x times cosine of x, which we write as cosine squared of x. Then, simplifying the other side, we have a negative times a negative, so that gives us a positive. And we have sine x times sine x, which would be sine squared x. That is divided by the square of cosine of x, which again would just be cosine squared of x. Here, we can simplify. If we look at the numerator, we should remember from a previous class that that is indeed a trig identity that we can make a substitution for. What is cosine squared plus sine squared equal to? Well, that is equal to 1. So we have here 1 over the cosine squared of x. But this can simplify further. Here, what is 1 over cosine squared x? We can break that up as 1 over cosine x times 1 over cosine x. What do we call 1 over cosine x? Which reciprocal trig function is that? Well, that is the secant function. So if we have 1 over cosine x, that is the secant of x, and again times 1 over cosine x, that is again the secant of x. So if you have the secant of x times the secant of x, what does that give you? That gives you the secant squared of x. So we say that the derivative of the tangent function is secant squared. Okay, so now I leave it up to you to find the derivative of the cosecant function, the secant function, and the cotangent function. These are your practice problems. How will you find the derivative of the cosecant function? Well, you express it as 1 over the sine function, and then you use the quotient rule. Do the same thing for secant and the same thing for tangent. Okay? And let's see what you get.